So to take these notes on sedimentary rocks, you're going to need your green notebook. You guys remember we have this green notebook here. We're on geology, section number 1, rocks and minerals. We're going to work here on Roman numeral number 5, sedimentary rocks and sedimentary rock formation. This starts on page 15. So here on page 15, you can see that we're going to focus our attention on sedimentary rocks, and your learning goal is you can describe how sedimentary rocks are classified. Set of sedimentary rocks, let's take a look at a few. These are sedimentary rocks as well as these. Notice that they all have something in common. All of these rocks are in layers. Sometimes the layers might be tilted like these here. Sometimes they're folded. They might cross one another. But all of these sedimentary rocks are in layers. So the first thing I want you to get down in your notes is this. If you see layers in a rock, you know it's going to be a sedimentary rock. Get that in page 15. Another characteristic of sedimentary rocks is if you see a fossil, like here we see some fossilized shells, then we know it's going to be a sedimentary rock. Fossils form when a dead organism is buried under more sediment and it gets caught within these layers of the sedimentary rock. So the reason we can see this starfish is when that starfish died, it was then quickly buried by more sediment and then got trapped in between the layers. So if you see any sort of fossil, you know it's going to be a sedimentary rock. So far, 2 things in our notes on page 15. Sedimentary rocks show layers and they have fossils. Now, not every sedimentary rock is going to show layers and fossils, but if you see layers, you know it's a sedimentary rock. If you see fossils, you know it's a sedimentary rock. Those are the different types of sedimentary rocks. Sorry, now we move on to the different types of sedimentary rocks. So we can see here on page 7 of the reference table, so please have out page 7 of your reference tables, there's a scheme for sedimentary rock identification and then a scheme for metamorphic rock identification. We're going to focus our attention here on the scheme for sedimentary rock identification. There are 3 types of sedimentary rocks. There's these clastic rocks, crystalline rocks, and bioclastic rocks. And we can see that on page 15 of our reference tables. We can see the clastic, crystalline, and bioclastic rocks that are there. Let's fill in the information that we have about those. So we start off with these clastic sedimentary rocks. Notice that there's also that word fragmental in there. So clastic rocks are fragmental rocks that are made up of fragments or pieces of other rocks. So when rocks get weathered and broken apart, they make pieces. When those pieces get compacted and cemented together, they make up a clastic or a fragmental rock. We don't care, they're the 4 rocks that are in your notes. We don't care what the pieces are made of, what the rocks are made of, their mineral composition. What we do care about is the sizes. If a rock is made up of pebble-sized pieces, then we say that that rock is going to be a conglomerate or a breccia. Conglomerates or breccia are rocks that are made up of fragments of other rocks that are easily seen. So here we have a conglomerate, and you can see that the pieces of this conglomerate are made up of pebble-sized pieces. Look at all of those little pebbles that have been compacted and cemented together. If those pebble-sized pieces are angular, then we say it's a breccia. If it's rounded, we say it is a conglomerate. If those pieces that make up the rock are smaller than a pebble, if they're sand size, then we have a sandstone. Here we can see a rock that has some obvious layering, so we know it's a sedimentary rock. If we look closely, we can see that this rock is made of tiny, tiny pieces of sand grains. So this sand grains, if it's made out of sand grains, would be a sandstone. So notice that the rock name is determined not by the composition, but is determined by the grain size. So if it's pebble-sized grains, makes conglomerates and breccia. Sand-sized grains make a sandstone. A silt-sized grain, of course, is going to make a siltstone. And a clay-sized grain, well, it's not claystone, but is called shale. Clay is so fine, it's microscopic in size, and it's difficult to see any of the pieces from clay. So here I have a piece of shale, and the shale is so tight, maybe you can see some of the lineations that make that a layer there. The shale is made up of clay-sized pieces, very, very, very microscopic and small, the smallest size pieces of our clastic rocks. So all the clastic rocks, or the ones that are fragmental, are based on their grain size. So 5 clastic fragmental rocks, the conglomerate, breccia, sandstone, siltstone, and shale, those rock names are based on their grain size. The composition is not important. It could be made out of quartz, feldspar, any mineral. What is important is the grain size. Also over to the right, you'll notice the map symbol of the rocks as well. If we look at a sand, for instance, a sand grain can be as big as 0.2 centimeters or as small as 0.006 centimeters, which is the size of the largest silt grain. The key about the clastic rocks, or the fragmental rocks, is that they're organized based on their grain size.